Hi everybody, hope you're doing well. This is my first nighttime video. I don't know if you'll even tell the difference, but generally I do my videos in the afternoons, but now it is nighttime. It's like after 9 p.m. and was so busy today that I didn't get around to making the video when I wanted to. So we're going to be talking about inverse relations and functions. So you will need your note sheet, the worksheet, and your graphing calculator. Now this is something that you will definitely see again as you go to higher level math classes, so it's really important that you pay attention, understand, and ask questions if you need to. So there are some information, there is some information at the top of the page, and I'm not going to read through that right now. I will just talk about it as it comes up in the problem. So let's just get right to number one. Okay, so the question is to find the inverse of this function. So this is a linear function because the x is just a single x, like x to the first power. So that is called linear. So we want to find what is called the inverse of it. So if you look at the top of the paper, it's the third sentence down, and it says to find the inverse of a function, you switch the x and y variables and then you solve for y. So that's what I'm going to do right now. I'm going to switch x and y. So x will be here and y will be here. And then I will solve for y. So to solve for y, I would begin by adding 4 to both sides. So the left side would be x plus 4. And on the right side, we would still have 2y because the 4's would cancel. And then I will divide every term by 2. Now, if you see x over 2, keep in mind that's really 1x over 2. So you can think of it as 1/2 x. And then 4 divided by 2 is 2, and the 2's cancel, leaving y. So your inverse would be y equals 1/2 x plus 2. Okay, so we found the inverse, but we want to know, is the inverse a function? So that's what we're going to take a look at next. And we're going to use our graphing calculator to do that. So I'm going to set this down and go to my calculator. Okay, I had already typed in the equation a few minutes ago, so you'll notice that is the answer that we just found. And I'm going to press graph. And you'll notice that it is just a line. It's a linear function. So we want to determine, is it a function? So you do what is called a vertical line test. So this is something that you all learned first in Algebra 1, but you probably forgot about. So what you do is you hold a vertical line, so say your pencil, on the graph. And say I hold it right here. The vertical line only goes through that graph one time. If I were to hold the pencil over here, it would only go through one time. No matter where I hold the pencil, it would only cross through the line once. So we would say, yes, that is a function. So for number 1, where it says, is it a function? Yes, this one is. Okay, so if you get an inverse and it is a function like we just determined, then there is a special notation that you need to use, and you will absolutely see this again in the future as you do higher level math classes. So it's the function notation, f, and then it has this little -1 here and an x. Now it's important to note that is not a -1 power, that is read the inverse of f. And then it would be 1/2 x plus 2. So the way you would write your final answer for number 1 is with this notation. So this would be called f inverse, or the inverse of f, and then it's 1/2 x plus 2. Okay, final answer for number 1 is this function notation, and then yes, it is a function. Okay, so let's check out number 2. So for number 2, our original equation is y equals -1/3 x plus 2. Okay, so we want to know what is the inverse first. So you're going to switch the x and the y. That's always how you start. And then you will solve for y. So in this case, I'm going to first subtract the 2. So then I would have x minus 2 on one side. I would still have negative 1/3 y, and the 2's would cancel out. Now, when you have a fraction multiplied to the variable that you want to solve for, you multiply both sides by the reciprocal. So the reciprocal of negative 1/3 would be negative 3. Now on this side, to show that I'm going to multiply by negative 3, I'm going to put parentheses around it. So then I will distribute the negative 3. So that would be negative 3x plus 6. And over here, the negative 1/3 and the negative 3 cancel, leaving y. So your inverse is y equals negative 3x plus 6. Okay, so I want to know, is this answer truly a function? So I'm going to go to my calculator and check out its graph. Okay, so I'm going to go to y equals, and erase what I had before. Okay, so now it is negative 3x plus 6. And press graph. So you will see that it is a line, and to tell if it's a function, you do a vertical line test. So again, hold your pencil vertically. How many times would it touch the graph? It only touches once. If I hold it here, if I move it over here, it only touches once. No matter where I hold the pencil, it will only cross through the graph just the one time. So number 2 also is a function. So where it says, is it a function? Yes, it is. So because this answer is a function, you would have to use the notation that I showed you a few minutes ago. So it would be f for function. This symbol is not a -1, that's an inverse symbol. So it's f inverse of x is negative 3x plus 6. And that's how you would write your final answer for number 2. This is just saying it's the inverse of the function f, or f inverse. Okay, so number 2 is also finished. Okay, so number 3, y equals 2x squared minus 6. Okay, so we're going to do the inverse of this function. So I will first, sorry, I just noticed that that was crooked. Okay, so I'm going to switch the x and the y, and then solve for y. So I will start off by adding 6. So x plus 6 will be 2y squared. I will also divide everything by 2. That's every term by 2. Remember, this is like 1x over 2, so that's 1/2 x. Plus 6 over 2 is 3. Over here, the 2's cancel, and that's y squared. So right now I have y squared equals 1/2 x plus 3. So we're trying to solve for y, not y squared. So at this point, I'm going to take the square root of both sides. Now keep in mind from earlier this year that if you take the square root, you must include plus or minus. So it would be plus or minus the square root of 1/2 x plus 3. Okay, so this would be the inverse, and then I would need to look at the graph to determine if it's a function. So I will set this down and go back over to the calculator. Okay, so I will erase what I had before. Let me close this door. My son is listening to something on his iPad, and I think it might be in the background for you. Okay, so let's go back to it. Okay, so notice that there's a plus and minus. You can't put the plus and the minus together on most calculators, so you have to write them as separate equations. So I'm going to go to square root, so second square root. I'm going to put in 1/2 x plus 3 So that would be the positive square root. Then you're going to come down to line 2 and do the same thing, but put a negative symbol before the square root. Remember, it's not subtraction, it's a negative sign. And then the same exact thing, 1/2 x plus 3. So notice the only difference between the two is that one of them is a positive square root and the other one's a negative square root. Okay, so go ahead and press graph. So it's going to appear as two separate functions, like one blue and one red, but it is not exactly two. It's really one thing. So you will do the vertical line test on it. So suppose I hold my pencil right here. How many times does it go through the graph? Twice. Even if I come over here, it's twice. So wherever I hold the pencil, it goes through twice. So that means that this is not a function. So for number 3, back over here, this one would not be a function. So if it is not a function, like this one, you would not use that F inverse notation like we did on numbers 1 and 2. You would keep your answer just like this with a y, and that is called an inverse relation rather than an inverse function. So the only difference between this and the previous two is that when we graph this, it was not a function by using the vertical line test. So no F inverse here, it will just be a y. Okay, so number 4, y equals x minus 2 squared minus 5. Find the inverse. So I'm going to switch the x and the y, and then solve for y. So first of all, I will add 5 to both sides. So I'll have x plus 5 equals y minus 2 squared, because the 5's would cancel. Now this time I'm going to need to get rid of the square now by doing the square root of both sides. And remember, whenever you square root both sides, you must include plus or minus. So it will be plus or minus the square root of x plus 5. And on the right side, the square root and the square would cancel, leaving y minus 2. And then I would add 2 to both sides. Now when I add 2 to the left side, it does not combine with this radical. It's going to be separate. So what I would do is put the 2 first. So it would be 2 plus or minus the square root of x plus 5 equals y. Okay, so I want to know, would this represent a function? So I'm going to go to the calculator and find out. Okay, so let's erase the other one. Okay, so we're going to write this as 2 separate equations again because of the plus and minus. And I'm getting emails even at 9:30 at night. Okay, so here we go. It's 2 plus the square root of x plus 5. And for the other one, you would put 2 minus. Now this is subtraction. The square root, x plus 5. Okay, so notice the only difference between those two is one is a plus and one is a minus because of the plus and minus. Can you all see that? I realized I had my camera turned a little bit. Sorry. Hope you can see that okay. All right, so now I'm going to press graph. And again, it's going to appear to be 2 separate things, but it's really just one. So hold your pencil vertically and think, would it pass the vertical line test? And in this case, no, it does not, because it passes through the graph more than once. So we would say that no, that is not a function. So even though this is the inverse, it's not a function, so you would not use the F inverse notation. You would just leave it as a y. So your answer would be y equals 2 plus or minus the square root of x plus 5. So this is called an inverse relation rather than an inverse function because it did not pass the vertical line test. Okay, so that would be the front side of your note sheet. There's a couple more things on the back. So let's take a look at number 5. So number 5 gives you two functions. One is f, and that is 2x minus 4. And the other one is g, and that one is 1/2 x plus 2. Now if you look at the way it is worded, it says that verify that these two functions are inverses of each other. So we already know that one is the inverse of the other. We want to verify it. And it says you're going to compare f of g of x to g of f of x. So this is the lesson that we did last time where you plug one function into the other one. So you always look at the inner function and plug it into the outer one. So this one would mean to plug g into f. So this is what we did last time. So for that one, you will take all of g and you will replace it for the x in the f function. So you're going to be rewriting f. So the 2 would still be there, but in place of x, you're going to put in 1/2 x plus 2, and then you still have to subtract 4. Now on this one, we're going to do just the opposite. You take the inner one and plug it into the outer one. So the f will go into g. So in this case, we're going to do the reverse. We're going to take f and plug it into g. So this time we're rewriting g. So the half would still be there. And instead of x, you're going to put in 2x minus 4, and then you're still going to add 2. So what we want to know is if these two things are the same thing. So we're going to simplify both of them and see if they are the same. So over here, you would distribute the 2 to both of these. So 2 times 1/2 of x would just be x. 2 times 2 would be 4, and then you would still have that minus 4. So if you were to combine 4 with -4, you would just have x. Then you're going to do the same thing over here. Distribute the 1/2 to both of those. So 1/2 of 2x would be x, 1/2 of -4 would be -2, and then you would still have that plus 2. So if you were to combine -2 with 2, you would have them cancel and you'd leave with x. So notice that in each case, we ended up getting an x. So as long as that happens, that means that the two functions that you started with really were inverses of each other. So that's how you verify that they are inverses. You plug g into f, and then you plug f into g, and if you get the same thing, then that's the way you verify it. So number 5 is done. Okay, 6 and 7 are going to be a lot like numbers, the ones on the previous page, but we'll have to graph them and look at some relationships. Okay, so for number 6, they give us f of x is -2/3 x plus 6. Okay, so whenever you see f of x, that just means a function, but it's the same thing as y. It just means that it is a function. It would pass the vertical line test. So like the earlier problems, I'm going to switch x and y. So the x would be over here, and the y would be here. I'm going to now solve for y, so I will subtract 6. So you'll have x minus 6 on one side, and -2/3 y on the other side, and the 6's would cancel. So to solve for y, whenever you have a fraction multiplied to a variable, you use the reciprocal and multiply. So it would be -3/2. So I'm going to multiply both sides by -3/2. And I did that on the left side by showing it with parentheses. So now I will distribute the -3/2 to here and here. So that would be -3/2 x. And if you were to multiply -3/2 times -6, you would find that answer to be 9. And over here, the 2/3 and the -3/2 would cancel, leaving y. So your equation would be y equals -3/2 x plus 9. Okay, so this would be the inverse. And it asks you to do that. but it also says to graph the original function and the inverse. So let's go back to the calculator and take a look at that. Let me erase these. Okay, so the original problem was negative 2/3. That's a negative symbol. 2 divided by 3, x plus 6. So it asks you to graph that function, the original one. So if you press graph, it will be that line. You will go to the table, since we have a graph to draw, and you would choose some of those values and plot them. And remember, you can scroll up and down on the table and plot some points. So I would just ignore the decimals and plot a few of the other points, like say for right there, there's negative 3.8, later there's 0.6, then there's 3.4, 6.2, and so on. So just plot a few of those and make your line. Okay, now we want to look at the other one, the inverse, at the same time. So go to line 2, and our answer was negative 3/2 x plus 9. And then also graph that one. So you get another equation, another graph I should say, and that would be the inverse. So you're going to graph that one too at the same time. So go back to the table and look for things to plot for x and y2. So again, you can scroll around and see what would be good, but let's see. Some of them are going to be too high, but there's 0.9, 2.6, 4.3, 6.0, and so on. Okay, so once you have those graphed, you might want to just stop the video and graph them. I want you to see a few relationships between the two. So while we're on the table, I want you to note that what we did with the original equation is we switched the x and the y. So notice some of the points on the table have been switched. For instance, on the original graph, there's 3, 4. So if I were to switch that around, on the other graph I should see 4, 3, and I do. There's 4, 3. And that should work for every point. Like back up here, I have 6, 0 on one graph, and the other graph has 0, 6. So the x and y has switched. Yeah, that would work for any of these things. So like for instance, I see negative 3, 8 on one graph. So if it was switched around, it should be 8, negative 3. And there it is, 8, negative 3. Okay, so that should happen on the table for all of the inverses. Now the other thing is graphically. If you go back to the graph, there is a relationship between these two graphs. So this was mentioned on the front side of the notes and part of the wording at the top of the page. And it says, let me grab my paper and say the exact wording that it has. It says, it's the second sentence at the top. The graph of an inverse relation is the reflection of the graph of the original relation with the line y equals x as the line of reflection. So what that means, if I were to graph y equals x, so come down to the third line and put in x there, it's going to draw in this line. That's the black line on my screen. The two graphs, the original function and the inverse, should be reflections of each other across that line. So you'll notice that the two graphs look the same on either side of that black line. So that should be the relationship every time that you have a function and its inverse. They should reflect each other around the line y equals x. Okay, so we have one more, number 7. So it's going to be similar to this one, but not quite. And I'm sorry this video is a little long, but this topic is pretty important for future math classes, so I wanted to take extra time and make sure you get it. So this video is probably one of the longer ones we'll do. Okay, so again, we're going to switch the x and the y. and then I will solve for y. So I'm going to add 3 to both sides. So it will be x plus 3 equals y plus 4 squared. I want to eliminate the square, so I will square root both sides. When I square root both sides, do I have to include plus or minus? And on this side, the square root and the square cancel out. So then I would subtract 4 from both sides. And the negative 4 would be separate from the radical. So you would put negative 4 plus or minus the square root of x plus 3 equals y. Okay, so that is the inverse. We want to see if that would be a function and how it would look graphed. So I'm gonna put this down and put those answers into my calculator. Okay, so let's erase this stuff. All right, so back up to the first one. Okay, so the original graph that we were asked to do has parentheses. So put it in with parentheses, just like it looks on the paper. X plus 4 squared minus 3 was our original function. So you'll note that that is a parabola. So you will need to draw that parabola on your paper. So you'll look at the table and find some values. And remember, you can scroll around and find things that will fit on your graph. So there's everything pretty much from -7 up until -1. All of those things would fit on the graph. So plot those. Okay, so for the inverse, you will have to draw it as 2 separate equations. So one of them would be -4 plus the square root, and it's x plus 3. And then the other one would be -4 minus the square root of x plus 3. Now notice there's a difference between the negative symbol and the subtraction sign. That's a -4 and that's a subtraction symbol. They are different. Okay, so when you graph this, it will look like it's 2 pieces, but it's really just one graph. And even with my calculator, it shows like a gap between those two. There's really not supposed to be a gap, so that should be filled in. It's just not able to see it too well on your calculator. Okay, so you will go to the table and plot some points. So you're going to be looking for x and y2, and then also x and y3. And you notice that some of the values give errors over here. That is because you would be doing the square root of a negative number, which is not real. Those would be imaginary. So just plot the ones that are possible, which would be the values down here. So you might want to scroll down past these errors to get to some more numbers that are plotted. Okay, so once you get those 2 graphs made, you may need to stop the video and plot the graphs. Couple things to note. So one thing is that the x and y values should be reversed from one graph to the other. So let's check out a couple of them. So notice on the original graph, there is -4, -3. So what if that was switched around? On the other graph, it's -3, -4. The x and the y have switched. So that's good. That's what we wanted to happen. Here's -2, 1. And if it were switched, it would be 1, -2. And that should work for everything. So there's -5, -2. And there's -2, -5 switched. So that should work for all the points. You should be able to find the opposite point, like the one that has been switched with the x and y in your table. The other thing to note is the graph. Graphically, these two should be reflections of each other around y equals x. So come down here to the 4th one this time and put in x and then graph that. So it's going to be that pink line on my calculator. So the graphs should look the same on either side of that pink line. Now you'll notice that it kind of looks distorted. and I don't know if I've ever mentioned this in class, but the x-axis and the y-axis is not really spaced the same way. Like if you notice here, the x-axis has a smaller increment than the y-axis has a smaller increment than the x. So that's why the two don't really look the same, but they really are. It's the spacing on the x and y-axis that makes it look a little off. But they really are reflections of each other around that line y equals x. So that would be their relationship. So I'm sorry that was such a long video, and I'm hoping that y'all are doing okay. Please ask questions if you get stuck on the homework, and I hope that you do well this week, and I'll talk to you later. Bye-bye.